Students, this question, I hope you have tried it now. If you could get the answer, that's great. This question, it's actually I picked this question. It's simply because we need to apply several theories. You see now, so they are telling we are compressing this spring. So the spring half kx squared, the energy, and the velocity when it goes from here, it's v, and basically we need to find the range actually. So range they have given as 2.4. So when doing actually this question, we need to have the knowledge from projectiles and yes, this strain energy knowledge and conservation of energy, of course. So let's apply our knowledge and then try to do the question. So basically they are telling when it is compressed 1.4, here see 1.4, that means when we give half k 1.4 squared, here actually we have to put it in meters, but I'm just putting it in centimeters because I'm not changing the units here. I'm just remember that we have to put it in meters, right? I'm just putting it in centimeters because when I'm dividing, it will cancel off. So that should be equal to the velocity, half m v squared. So here it's projected with that velocity v, right? So let's do simplification now. Half and half cancel off, of course you can see it. Half and half cancel off. So v squared equals, we can get k into 1.4 squared divided by m, then v will be root of this value. That's the projected velocity. Right, let's apply it now. So now we know the velocity v here at this point, it's 1.4, this one, right? Another thing we should remember in projectile questions, we have two scenarios, first this point and this point. For both situations actually time is equal. See now here the vertical displacement is same for both cases, so we should remember the time is for the entire projectile, the time is same. So if you are applying the equation for r, the range is equals ut, because we don't have half ad squared towards in horizontal direction, so I can take u as root k 1.4 squared over m into t, that is, let's write the value. They attempt for 2.4, but it was just short 30 centimeters. So 2.4 minus 0.3, so it's 2.1. So it's 2.1 here, right? These are first two equations. So what I'm going to do is I'm going to take two equations for both two scenarios and try to find the value they're asking for, right? So if it's projected with the proper velocity, it should land at 2.4. And the velocity I'm going to take from the previous equation k. So here 1.4 should be x squared. Let's see, this is the value we are looking for. M of course same, time same as I mentioned earlier. So this is our second equation. So what basically we should do it, we have to divide these two, right? Let's try dividing these two now, right? First equation divided by second equation, right? I'll write the values. 2.1 divided by 2.4. Right, here you should remember, students, this k value, k is equal m, these values will cancel off. Of course t will cancel off. So we'll be getting something like this now. We have root, of course, 1.4 squared divided by, we have x squared. Simple simplification now. So we can take the root, we can take off the root values. So 2.1 over 2.4 equals x, 1.4 over x, right? So let's subject value of x equals 1.4 into 2.4 divided by 2.1. So I can simplify this by 0.7, 2, 0.73, 3, it's 0.8. 2 into 0.8, it's 1.6 the value. So x actually I didn't remember. When I'm putting the value, substituting the value here, I put it in centimeters. So just like that, the x value will be in centimeters. You have to remember these things. Let's go to our answers now. Yes, here you can see they have given the answer 1.6 centimeters. Students, if you need to practice, yes, there are few questions in the playlist. Go through the playlist. You will find similar type of questions. Practice is the key here.